This is example 5.3.9. It says a force of 100 newtons is exerted upward on a book with a mass of 5 kilograms, initially at rest for 1.8 seconds. It says at this point the object is dropped. Construct a free body diagram for before and after. So the one thing that you should notice right away is there are actually a lot of numbers in here. Not all of them are going to be relevant because what we're trying to do is we're trying to calculate a free body diagram. So it says first of all we have a 100 Newton force that is being exerted upwards. So here's my object. It's our book. We're going to be talking about before when it's being lifted. You have a force of 100 newtons that is exerted upwards. It says you have a mass of 5 kilograms. And here's where a lot of people make the mistake, is they'll put this down arrow and they will confuse mass with weight. Remember, they are very different things. So you can't put just a 5 value here because that doesn't make any sense. You're talking about kilograms and then on a free body diagram. So what you have to do is you actually have to calculate and say, okay, force of gravity is equal to mass times gravity. So really what this value here is 5 times 9.8, or 49 newtons. So this is our before diagram. We have 100 newtons up, 49 newtons down. If we wanted to, we can say the sum of the forces is 51 newtons up. It doesn't ask us to do that, but we could. Now, afterwards, it says at this point the object is dropped. And this 1.8 seconds is actually irrelevant. I mean, you could figure out at this point, you could say, oh, okay, well then what is the acceleration of the book? How high is it going to be? But it's irrelevant to finding what the free body diagram is. So once the object is dropped, once it's let go, this upward force no longer exists. There's nothing pushing it up. But the gravitational force still exists. Now, a lot of people want to say, and we can call it FG as well if we wanted to, a lot of people want to say, okay, well, how come I have the same gravitational force when the object is moving up and when the object is falling down with free fall? Remember, the weight of an object isn't going to change. What changes is this: if there's a larger force going upwards. In our case, there's not. Not here whenever it's dropped.